Oh, okay, it's fine to go? Perfect. Hi everyone, great to see so many people here. My name is Tomasz Stanczak. I work for Nethermind. At Nethermind, we build two things mainly. One is a infrastructure Ethereum client, full Ethereum client. Currently one of the major ones, but still probably like with 0.5% of the market share. But it's growing, so I encourage you to try it. The second thing that we build is what we call data marketplace, and at some point maybe we'll get some different branding, but for now we call it Nethermind Data Marketplace to describe what it does. It helps to sell data. Now, we are in a rare position where we actually deliver the infrastructure, the actual Ethereum client. We work on the protocol as core developers, participate in the network improvements, and we also quite a heavy user of some of the protocol functionalities for building this data marketplace. So where the idea for the data marketplace comes from and what problem does it try to solve and how we approach it technically, because this is what I want to tell you about. I used to work in a financial services, sell side, buy side, first in a bank and then in a hedge fund. And I can give you one example when we were preparing for one of the major events in the financial markets that would impact heavily the actual prices in the markets. And while being in the hedge fund, everybody was working hard, preparing some last-minute tools to collect data and so on and so on. One thing that happened was, you know, if you received a contract to sign that you really will not tell anyone what you're doing, even as you signed it already when you were joining the company, you would feel this seems to be very important. And then imagine that actually someone paid attention to print it in red. That's what I received at that time, right? I had to sign a contract that was printed in red, that it felt like it was written in blood. That's how much they cared about not only not telling everyone else what tools we use, what financial models we use, but also not even telling anyone what kind of data we consumed. Not telling in what direction we are looking at a given time. And when you think about the decentralized finance of the future, I think that while now we connecting all the money Legos, we use smart contracts and so on, when you consume data, it's still the data that's coming from centralized services for the centralized world. So there are data collectors that collect from decentralized exchanges, centralized exchanges. We can connect all of them together, pay money, either maybe in crypto, but through some facilitators, payment facilitators, or by card and so on. What we deliver is ability to connect to the network, discover the sellers of data, subscribe or buy data streams or data assets, API calls, invocations anonymously, and establish the kind of like a tunneled one-to-one connection between the seller of the data and the buyer, which means that you have anonymous consumption of data. You have data that is potentially protecting the seller of data if you can automatically watermark it per the key of the buyer, and if you connect it with some additional de-anonymizing KYCs, if you have such requirements, then you can maybe track if someone is reselling your data, republishing it. It is encrypted if you need it. It is also, in a way, unstoppable. So when we were talking about unstoppable contracts in the past, Ethereum as the unstoppable execution, I can think about unstoppable data in a way that we deliver the tools which allow people to use a single smart contract to facilitate this delivery, sales of data, subscriptions that we as a company have no way of stopping, preventing from starting being sold and so on. And also we don't have any knowledge about who is buying what data. And this is important because this knowledge about what kind of data you're trading on is important for allowing you to actually use some market opportunities. And now, when we come back to the actual Ethereum protocol, one important problem for us to solve for having this fully controlled experience of consuming data was how do we make sure that the consumers of data do not have to go through MetaMask, through Infura, they don't have to connect to external nodes, and so on. So obviously, we are in this position when we can say, oh, we'll deliver to you a full integration, data packages, some connection to the network, and also the node itself. But the problem is, and that was a common question at the beginning, we could only promise that we can solve this problem, but it was hard. How do you actually connect to the mainnet with this full verification of the money that you're spending on data, the money that you're receiving for data if you're selling it, without spending hours or weeks on synchronizing the mainnet. So the Nethermind client, the Ethereum client, became for us a very important tool to deliver that functionality. And through the recent research on the stateless Ethereum, there is a list of talks in the other room that might be worth to see as well. We started working on different solutions for stateless clients, for rapidly syncing clients that can jump straight to the head of the chain and verify. And practically that's what we have now. When you install the solution, you can launch it, and in like under a minute, maybe 15 seconds, jump to the head of the mainnet, verify your contract only, some checks, basic checks on whether people are actually paying for your data, if your payment was processed, and then go forward. And that's particularly important for any decentralized application that says, okay, we don't want to bother our users with running the node, but we want to promise them that it's actually anonymous, decentralized, and fully controlled by you. That you're not dependent on the fact that Infura maybe go down, or Alchemy will go down, or whatever other solution like this will go down. And again, even nowadays, most of the hedge funds will not run their critical infrastructure on the cloud. They will have it on premise with some pretty serious solutions to ensure that this part is never shared with anyone. And the node is part of it. If we have time, I'll try to show you quickly the demo of this mainnet beam syncing. The monetization model and fee structure, because for many people who try to build businesses around decentralized finance, around Ethereum, this is always a question. So we tried to keep it simple. We decided very early that we ourselves would never go the ICO token way, that particularly the models from the past were not really aligning interests of the builders of the protocols with the interests of the investors or users. So the simplest way, but not always possible, is to just collect fees on the percentage of the processing. And we see that in decentralized finance nowadays, it's very common, right? So if you can onboard most of the applications, stop thinking about the fiat to crypto on-ramp too much. If your processing is going through your system, through your smart contracts, then you can charge a small percentage fee based on all the payments that are happening in the system. So now I'll try to connect quickly the beam sync, show you how it improves the experience, solves the problem for us. Depends on the internet connection to some extent, but sorry, just one moment. Once again? No, it's fine, it's fine. Okay, in a moment we should be there. So the whole idea of beam sync is you catch one of the pivot blocks from recently, so for example, a few thousand blocks behind, and I think I stayed on one of the blocks from 2 days ago, so I didn't change it. And we are now synchronizing this latest headers. The internet connection is really bad, so we just need to wait a moment, I think. And so maybe it will take just 2-3 minutes, but in a moment we'll be on the main. Oh, that's why you were asking if I need help, right? Oh, wow. Okay, I didn't know that it disappeared. So, yeah, I do need help then. So you see the current blocks on the mainnet is 9.6 million, right? And yeah, it will be hard with this internet, I guess. That's the problem with live demos. So like, I should be throwing stones at the car now. The thing is, I didn't touch anything since I ran this live demo last time. All right, let's give up. So what I can show you, maybe you'll have more luck here. No, not this folder. So if I go to EtherScan once again, but I'll go to girly one. I'm just using slightly lighter chain. So we see 2.292 million blocks. A few minutes. That's like 30,000 blocks on a very slow connection. We'll be there in a moment. So, like, you have to assume now this, on a normal sensible connection of any business that would consume data, it would go like in 5 to 10 seconds, right? So this is normally like a one lock screen if everything is running sensibly. In a moment, we'll be able to run on this chain the actual full tracing of the transactions that are touching some of the smart contracts. So this is not possible normally with the light clients, because of the light clients you collect proofs, but not really the ability to run the full state. And here I'll just launch the CLI on the side. All right. And what you see here on the side is actual girly chain that normally if you wanted to full synchronize or fast synchronize even would take you maybe like 50 minutes now for the full archive, maybe 10 minutes for fast sync if you did it with Nethermind. But potentially here, I think it took us maybe 1 to 2 minutes to synchronize, but that's because of the bit conditions. Like on the mainnet, again, fast syncing mainnet would be 6 to 7 hours, Nethermind, and you can jump to that in 1 minute. And I can take one of the blocks here. So I see now that the chain is already at the head, and I'll take that block, And ideally, I would find quickly on Gerli Sam block with the transactions. So 2287 has 3 transactions here. I hope you see that. Yeah, OK. So we were probably there. However, I'm not sure. This is after the sync. So let's refresh it. 300. OK, 299. Yeah, OK. So I just retrieved the block with transactions. The block has 3 transactions here on the list. And I'll get one of those transactions, I'll memorize its hash, and I'll try to run the replay. So this is a parity trace of the transaction. It could be also the debug trace of the get style debug. Let's see that quickly as well. Yeah, OK, so this is debug trace with whole virtual machine execution and so on. So what you can do with it, you can run, OK, one more important thing here is it's running entirely in memory. So you can run it as a server next to your applications. It does connect to mainnet. It verifies the historical call. It allows you to trace, to check the logs. It allows you to analyze the execution of your smart contracts. What's sometimes even more interesting, like what we do not create any logs from our system. So we don't use the emitting logs from Solidity. Instead, we're just analyzing the actual states of the contract because emitting logs is quite expensive when we look at the gas cost, and we're trying to save as much as possible, squeeze out of the gas costs. So our contracts that support data marketplace, when you buy data and sell data, so normally when you think you're touching blockchain, many companies will try to push quite a lot of things through the blockchain, right? What we do when you start subscription for a month, for example, you touch the blockchain, you pay 40,000 gas, and at the end, when you claim as a provider, you pay something like 60,000 gas. So altogether, the interaction between the buyer and seller of data is 100,000 gas, and then apart from that, we open a payment channel that allows them to make claims, payments, and so on. Okay, so I think more or less this is the time that I had, and I'll be open to get some questions from you now. Don't be shy.
Yeah. So the question, I'm just trying to understand one thing. You're probably a better expert in the clients. You know, if you look at Ethereum mainnet, you see that probably like 10% of blocks have 0 transactions, and I wasn't able to find anyone to explain to me why are these miners not actually mining any transactions? Why are they mining empty blocks? Do you know anything about this?
Yeah, sure. I mean, when you build a block, you build it like a ladder. You slowly start building better and better blocks. When you switch to the head of the chain as a miner, the first thing that you do, as quickly as possible, you generate empty block because it's the fastest, and you try to solve it as a riddle for the miners. In the meantime, you build better and better blocks that take slightly more time to access state, to execute, and you replace the block that you built with the better and better ones, because the sunken cost of your mining doesn't matter. You can switch the block that you're mining at any time. So if the miner finds something very quickly on the empty block, they will push it, and then we end up with it. This is, like we are talking now about the stateless miners and so on, so the ability to actually, as a miner, have access to launch a node like this in memory very quickly to produce potentially some of those empty blocks while they're using a full client for mining better blocks, potentially the ones that are using the infrastructure and decentralized finance. Okay, any other questions for Data Marketplace or BeamSync or Nethermind? No, thank you so much. Thank you so much for listening. Thank you. Thank you.
HDMI cable here. Yeah, of course. The mic. Okay. Do you need this for the presentation?